Hi all. So we all know a movie named Matrix came in the year 1999, acted by Keanu Reeves. It's a very famous movie. But the question here is, how does this Matrix movie related to the Google search engine? So this link between the Matrix movie and the Google search engine comes from this book called Matrix Methods in Data Mining and Pattern Recognitions. This book, Matrix Methods in Data Mining and Pattern Recognition, was written by Professor Lars Eldon from Linköping University, Sweden. So this matrix methods in data mining and pattern recognition book covers three aspects. One is it describes about the properties of matrices and the algorithms in matrices and what are the data mining and pattern recognition problems and how those algorithms of matrix methods can be utilized to solve this data mining and pattern recognition problem very efficiently. So this book covers three parts. The part one is covered about basic uh, um, methods involving vectors and matrices, like what are the properties of matrices and what are the operations involved in vectors and matrices, like matrix multiplications, matrix vector multiplications, inner product, outer product, matrix norms, what are the properties of the linear spaces and orthogonal spaces and the rank of a matrix, and what about matrix decompositions like LU decomposition, QR decomposition, singular value decomposition, and some properties of the matrix like condition number, rank deficiency, and how those operations are the properties of the matrices or matrix factorizations can be used for data mining applications, like solving data mining and pattern recognition problems that we come across in everyday life, like classification of handwritten digits. Like there are a bunch of handwritten digit images, and we are using some matrix methods to classify those images. If we have an unknown image, we have to identify whether that digital image belongs to any of the digits from 0 to 9. And it also applied in text mining. So we have a bunch of documents, and we have an unknown documents, and we wanted to identify which documents are very correlated with this query document. And it also helpful in page ranking the web search engine, like what is Google search engine is doing right now. We have a bunch of documents. We For a query word, it retrieves a bunch of web pages. From that web pages, which are more hierarchically correlated from top to bottom, is termed as a page ranking. That is been done through some matrix method that we will be come across in later videos. It also helpful to do some face recognitions in an efficient way using higher order singular value decompositions. And final chapter would be a specialized algorithms for especially applied to large and sparse matrices, like solving eigenvalue problems and identifying the singular values to eliminate noises in the matrices. So we begin with the part one. The chapter one is giving a very basic introductions about uh, what is data mining, what is pattern recognition, and what are the vectors and matrices are, and how those are applied in various data mining applications. Some examples of important data mining applications are briefly mentioned in this chapter. So the chapter begins with that in this today's world there are a huge amount of data is collected, and it is very necessary to extract these useful informations. So the science of extracting this useful information from this large unstructured data is termed as data mining. And pattern recognition is similar to the definition of data mining. It tries we have some raw input data input to the algorithm and try to bring some actions like categorizing those patterns or identifying those patterns from those raw huge data. So there's so many applications in today's world like e-business like Amazon's and scientific applications in bioinformatics retrieval, and also it utilizes, as we mentioned earlier in the title, in Google's internet search engines. It's truly interdisciplinary. It's not only the mathematics involved in it. It involves a lot of computer science. It involves statistics and data retrieving and data preparations, cleaning, and structuring the data. And also, as to this book is about that applying mostly numerical linear algebra matrix methods for data mining and pattern recognition. And of course, optimization is also very much utilized to solve these problems. So it's not emphasizing that everyday life we are come across in today's in this world is filled with data mining problems, and those data mining problems are solved through advanced mathematical methods. So this books gives you an overall idea of introduction to these methods, mathematical methods for solving data mining and pattern recognition problems. So, what are the vectors and matrices? As we have some basic background. So, we all know that matrix is a two-dimensional array of numbers, and it has rows and columns. And this is column one, this is column two, and this is going to n columns. And this is row one, row two, and it has m rows and n columns. So how do these data are embedded in this and that information in this data are embedded as a matrix. So basically solving the data mining problems involve in three tasks. One is problem descriptions in the real world, like how to retrieve the informations from the Google search engine. That problem description in the real world has to be transformed into a mathematical problem, like embedding those information into a structured data like matrices. And we use matrix methods like singular value decomposition, QR decomposition, subspace projections, all those things that we'll be covering in the forthcoming videos. That those things are being utilized to solve some of these real world problems. So here this book gives some 1 to 3 examples of what types of data mining problems that we come across in everyday our life. The problem one is like retrieving informations from the bunch of documents. Say we have some very trivial document one have this content, document two have this content, document three have this document 4 have this content, and document 5 have this down. So we have 5 documents, and we try to retrieve the keywords from the documents and make formalize the problem in a mathematical world as a term document matrix. Terms are in the row wise and columns are in the documents are in the column wise. And we formulate the term document matrix which are very sparse. The sparse matrix means mostly it's filled with zeros, and rarely it filled with the non-zero. Here is 1. Our query document is also formulated as a vector in a 10-dimensional space, and our goal is to identify which column is mostly correlated with this query documents. So the detailed algorithm will be detailed in chapter number 11. So here, for example, it has been given as a 10-dimensional vector, but in real world applications it would be a million or billion dimensional vector space. So this is one thing. And another thing is matrix is not only being regarded as a bunch of numbers. It's a very powerful. It's regarded as a very powerful linear operator. It's operating on the vectors, and that have some kind of a linear transformations, which we will cover later in what does mean by linear operator, what does mean by linear transformations, how those ideas are utilized to solve these data mining problems. The second example is, as I mentioned earlier, classification of the images. These images are digits with 0 to 9, and those images are pixelized, digitized images 16 plus 16, and we try to restructure this as a single dimensional vector of dimension 256. And we have bunch of training data, and our query image is also 256 dimensional vector. Then we want to identify we do some initial training stages using the training data, and during the query time we are utilizing those trained algorithm to identify what the test image belongs to, either to 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8, 9. So those what algorithms is involved, how those subspaces are built, how that query is projected into those subspaces, and how what error metrics we are utilizing to identify the query digit to the unknown digit. So that will be covered in chapter 10. So the third task is, as mentioned related to the title, is about Google search engine page ranking. So we build, there are a lot of web pages, billions of web pages. Those web pages are linked to each other in a different weight pattern. So those informations are taken into a mathematical term called link graph matrix, which will be end up this above graph would be end up with this link graph matrix. From this link graph matrix, how for a query vector we were retrieving those pages, and what pages are very relevant to this query problem, and ultimately it involved into solving an eigenvalue for the very largely built Google matrix. So as I mentioned earlier, the purpose of the big is to introduce some numerical linear algebra concepts, how those numerical linear algebra concepts are applied to the data mining and and most of the codes and algorithms are done in pseudocodes are done in MATLAB based environment. And this, I'm not going to go deep enough that it says about that how that numbers are represented in computer, that we all know that it is represented in floating point error, and it meant to have some errors, and if those errors are not overlooked properly, then in the algorithms it may blow up and the algorithm may become stable. So how these floating point numbers are taken into account so that the algorithm doesn't blow off and doesn't give erratic answers. So hopefully we see you in series of videos covering these chapters, and we will have some base. We will cover part one, basic vector and matrices algorithms, and part two will be covering what are the applications like classification of handwritten digits, information retrieval from a term document matrix, and page ranking, face recognitions. And finally, we will have to look at some specialized algorithms called that. So hopefully we'll see you in the next video. Thank you for your patience. See you.